Welcome everybody to this session, which is called Hypercube and Eclipse SDV, Key Connected Car Services in Action. My name is Sebastian. I'm a senior technical architect at T-Systems Germany. I'm working in the SDV tribe, and I'm one of the solution architects of our commercial product, Hypercube. But within that commercial product, we also use Eclipse components, and we also made our first contribution open source, which comes from the Hypercube program. So this is why I'm talking here today, to show you and explain you how we benefit from Eclipse open source projects, but also contribute back. Agenda, well, regular stuff. We start with a short introduction, then I give you, because I'm not sure if everybody's coming from the automotive background, what are the current challenges and concerns in this domain, then showing you what is an OTA update platform, over-the-air update platform, and then at the end we will take a closer look at our solution Hypercube and how Eclipse contributes to that. But first of all, and that's usually my favorite slide, because if you are from Germany or from Europe, you are very familiar with that magenta color. You know, it's kind of omnipresent out there. Everywhere there's advertisement, everybody has seen it. But usually we are not, you don't think of vehicles or the automotive domain when you talk about Deutsche Telekom or T-Systems. But the truth is, especially T-Systems was found or based on the automotive business. So the first ever department that T-Systems had was an automotive department. Of course, nowadays we have a lot more, but still, automotive is within the DNA of T-Systems. So you can see it, we are the #1 in Europe for connected vehicle business. We are doing development, integration solutions, operations, and also a lot of consulting for all the big OEMs in Germany and also some over Europe. So some impressive numbers. We're working with all the big clouds. Actually, our solution, Hypercube, is cloud agnostic, so in the end, we don't care on which environment we run. The fun fact, you don't see OTC over there, and probably you have never heard of it. OTC is Open Telecom Cloud. We have our own cloud offering, but we do not list it there. That already tells quite a bit about that offering. It's not that relevant, sadly, in the market, so even we don't use it. Okay, so that's about T-Systems, why we are here today speaking. So next topic is transformation of the mobility industry. If you bought a car 20 years ago, you basically bought a piece of metal with an engine and not too much technology inside. And this is currently tremendously changing, and that's a huge shift for the automotive industry. That's actually, I'm not that long in the automotive industry, why it became interesting for me, because it's not that metal focused anymore. Now it's becoming a smartphone on wheels, as we usually say. And the reasons why this is, well, you all have heard of these topics. Autonomous driving is everywhere. Yeah. We also contribute to that part. Not too much, to be honest. Not as good as Tesla, for example, for sure, or Mercedes, but we also do some research, some contribution. So also within T-Systems, autonomous driving is a topic. Our focus is rather on connectivity, and that of course makes sense. As a subsidiary of Deutsche Telekom, we have direct access to 5G antennas and the APIs. This is where our strength is, our logo is. We won't stop until everybody is connected. So this part, especially now, vehicles becoming connected, talking to the cloud backend, but also talking to each other, driving around, talking to traffic lights, talking to parking lots, and so on. This is where we see our strengths, where we focus on. Next topic is electricity. Okay, I think everywhere we are undergoing this change now. The integrated combustion engine will more and more fade away, will be replaced with electricity if we like it or not, doesn't matter. It seems it's happening. And with that comes a lot of software, of course, within the car. So again, it becomes very interesting. And the last part, shared services. So our assumption is, and many assumptions from experts, is that in the near future, we will stop having our own private car, and the sharing car business will grow and grow and grow, especially based on the autonomous part. Imagine you have your smartphone app and you can just, like you have Waymo already in Seattle, you can just order your car with your smartphone app and it will be there within minutes. You can go anywhere and you will only have to pay for the ride, nothing more. You won't need a car anymore. And this is probably going to happen quite soon. Let's see, in Germany it will be a bit late, but in other countries, sooner. So this is what is currently happening in the automotive industry. And this is a huge challenge for OEMs because they come from this metal business. They are good with metal, with bending metal and, painting and all that kind of stuff. And now they have to focus on software and software development and software lifecycle management. That's all new to them. That's really a big challenge for them. That's why we are there in the game, because that's what we are good at. So we support the big car manufacturers with these topics. This is an overview of what's going on, where we are active. All the kind of things where nowadays more and more software comes into the game, becomes relevant, and where we all like to contribute. And here, for all these kinds of services, and this is where our focus is, again, connectivity, over-the-air updates, you need to update all these kinds of things. Just like your smartphone, either is this Apple or Android or something else, the manufacturer of that phone will provide updates to you every once in a while. You can just download them over Wi-Fi or cellular network, doesn't matter, and you will get features, new features, bug fixes, and so on. You don't have to do much. And that's the same challenge for cars, as the car is now a smartphone on wheels. Yeah? Same situation. The problem here is this device is way more difficult than a smartphone. That's the problem. Why is it way more difficult? You have to support more products and longer generations. So especially, I think, in Germany or in Europe, you have laws that if you produce a car and it comes to the end of its life cycle, you still have to support software updates and bug fixes for it for an extended period of time of 10 years. So that's 10 years. Who has a smartphone that is older than 10 years? Probably nobody, yeah? You usually change it every 2 years. But here you have to support long generations of devices, different devices. Inside a car are many different components. So if you take a look at a smartphone from Apple, okay, it's a one device. They come in 2 editions, and you know exactly what's in there. If you buy a car, it doesn't matter which brand, you can configure it. And depending on your configuration, you will have very different devices inside your car. In addition, an OEM always tries to stay independent of a supplier who will provide these devices to them. So they will always at least use 2 different devices from 2 different suppliers in their vehicles, often more. So you have many more components inside, and these are even more different. And each of those have a lot of parameters. Well, that's quite similar to the smartphone. And you have a lot of interdependencies, because usually you have certain devices that focus on certain areas within the car. For example, you have one for focusing on the braking system, another one focusing on in-vehicle infotainment, and so on and so on. And all of these somehow need to communicate with each other. It's not that complicated in a smartphone. And then you have these complexity multipliers on the right-hand side, which always come into the game, because cybersecurity, so security, is a huge topic. As your car is now always connected to the internet, it's an attractive target for hackers trying to, you want to create a bad update and it will destroy something or it will block it, so you have to pay that you can use it again. Well, I haven't heard of such a use case yet, but theoretically, it's possible. Connectivity. We know that very well in Germany, even so Deutsche Telekom does quite a good job. You somehow have holes in your connectivity. When you're driving somewhere on the countryside, suddenly you don't have any connectivity anymore. That's quite a challenge if you want to do an OTA update. The performance of that connectivity is very, very different. And as always, our favorite regulations when the state comes into the game and tells you how you have to do something. So if you take all of this into the game, it makes a bit clearer, hopefully, that over-the-air updates for vehicles is way more difficult than for your smartphone. I have to use this one. Okay. Good. So how does our solution to that problem look like? So that's our end-to-end view on the over-the-air platform. So on the left-hand side, you have some cloud solution, an OEM backend, where your updates are placed. Usually when they undergo some tests, you upload them into the cloud, and then they're sent over or downloaded by the vehicle over a mobile network antenna. And this is where it gets a bit special. You won't see that by any other automotive supplier company, because usually they do not have these antennas under control. And that's a big differentiator between T-Systems and the other companies, because we are part of Deutsche Telekom, so 50% of the antennas in Germany are operated by us. That gives us the opportunity to say, hey, dear OEM, you would like to run huge over-the-air update campaigns for your vehicles. That means you want to transfer terabytes of data over these antennas. Why don't you do it at night, for example? Because at night, most of the people are sleeping. We can offer you discount rates. So this is our unique selling point, where you say, okay, if you want to do over-the-air updates in Germany or in other countries in Europe, do it with Deutsche Telekom, because we can give you a huge discount on this terabytes of data. And in the end, this is where the data needs to go, inside the car, to these many different devices. Okay. So this was a generic overview of an OTA update platform. And this is our concrete solution to it. So this is what I'm currently working on. This is the Hypercube platform. So it has an in-component part, which is called OTAS. It's the over-the-air server inside the car. It's kind of an update manager that does the downloading and also checks the integrity, and then applies it to the other devices within the car. And so within here, we see there could be a problem. So inside the car, this device will identify there's something wrong. We'll do some communication over command and control. It's kind of a communication layer, because each in cars, it's not a standardized way of communication, so you need to adapt to the protocol of the car. There you get the data together, you forward it to digital twin. There we apply a certain standard to it. So usually the data comes in binary format, and then needs to be transformed into something human or machine readable, and then gets forwarded to VOC, which is one of our cubes, Vehicle Operation Center. And there you have data analytics and visualization opportunities. So in there you will see, okay, this car will create kind of an error, and so it will pop up on your screen and say, here, there's something wrong with me, please do something. So we can then read the logs from the car, do normal software development, identify the bug, implement the bug fix, provide it to DC. It's another cube, Developer Console. In there we check, does this bug fix actually work? We roll it out to a testing car. Then forward it to packaging service, PS. Packaging service is basically a zip file machine. It will create a zip file out of this binary with some meta information, and then make it downloadable for the car. Device campaign management. Usually when you roll out software to vehicles, you do that via campaigns. So you decide, okay, I want to update, for example, all Volkswagen ID3 that have a certain configuration. That would be then a campaign. And then via digital twin, this is communicated to the car, going through back command and control to the car, and the bug will be fixed. And if we are really, really quick, vehicle should be working again within minutes. That's the theory. Let's see how it works in real life. But that's our circle, how we see the world. The car is at the center, and we provide the cloud backend platform to make it run. I already mentioned these cubes. It's just another overview. We have 6 cubes or 7 cubes at this moment in time. Device campaign management is doing these orchestration of campaigns to update certain kinds of cars in certain waves. Digital twin is a translator between the binary format of the car and the more understandable, readable format. We have Vehicle Operation Center. It's like a bit like Excel. So you have huge tables of data, and then you can create pivot tables and stuff like that to do analytics, but also it does alerting. We have task management. It's a workflow solution because all of these things have to work somehow together. Packaging service, already mentioned, doing zip file creation and putting them on a CDN. And then we have DCO, Developer Console. This is a release management tool where we verify that a new software package is valid and can be rolled out. And this one is open source. If you want to Google for Eclipse SDV Developer Console, you will find this cube open source. Okay, so I already mentioned it, just to mention it again. Within Hypercube, we focus on connected services and infotainment. And the goal is basically we want to bring the DevOps cycle, the well-known DevOps cycle, to the automotive world. So if you're longer already in the software development, like I am almost 20 years now, DevOps is nothing new to you. But if you speak to an automotive OEM, to a car manufacturer, they are not that familiar with DevOps yet. They will still take some time. They like the V model very, very much. So it will still take some time. So this is where we focus. With Hypercube, we do not do automated driving. We do that in other domains, but not within Hypercube. We do not do ADAS, and we definitely do not do anything with body and chassis. So this is our sweet spot with Hypercube. So this would be the architecture. So how does it all work together? Basically, we've already seen it with the cycle. It matches this kind of architecture. So down here we have the car, which communicates with this integration layer called Command and Control. Then we have digital twin that supports the Vehicle Signal Specification standard, so standardized format for data related to the automotive domain. Device campaign management to do the orchestration. On top is Developer Console as a release management. And on the top of everything is Vehicle Operations Center, kind of a data lake solution where all the data goes in and you can do this analysis and visualization. And here's packaging service doing the zip files. And task management on the right-hand side, responsible for workflows. So this is our usual Hypercube end-to-end demo that we do. Usually that tries to cover the whole software lifecycle management and the over-the-air update process. So this is if an OEM is interested in this kind of solution, we do exactly this. What is stated there, I will not go through it. It will take too long. And also the demo would take too long. I cannot do it here. It takes about 30 to 40 minutes. So I have to stream down a bit and say, okay, what's relevant today? And what do we want to focus on today? Now we're moving a bit away from the general overview, but looking more into technical details. Okay, here's this one. So that's, again, the general architectural overview, and the focus will be the digital twin now. So we will more or less ignore all the rest and focus just on digital twin. So, okay, there's a slide been missing, doesn't matter. Digital twin uses two Eclipse components. That's what I also would like to emphasize today. Another component within that architecture, so we put Developer Console open source, but we also use Eclipse components within here, within the digital twin. Exactly two. One is Hono. I don't know if you've heard of Hono. It's quite an interesting solution to do some kind of data routing, integrating different kinds of protocols, HTTP, MQTT, and so on, and then forwarding it to Kafka or ActiveMQ protocol. And that's, in the end, exactly what we need within digital twin. So if we go back to this picture here, as I said, we do not know what the car would like to speak, which protocol, which dialect. We're working with some OEMs, they use lightweight M2M. Who has ever heard of lightweight M2M protocol? You did, okay. You're in the automotive business, good. But it's not the very most popular protocol in the world. So most other OEMs use MQTT. But in the end, we do not know. Every OEM will use some different protocol, so we need to adapt. And that's where Hono comes in handy, because it already supports a lot of protocols. And the most important one actually is MQTT. How do we integrate that? So on the left-hand side now, devices would be like in the car, emitting data. Then you have different kinds of adapters for the different kind of protocols. You forward the data, And in the end, what we use then internally in our cloud systems is a central Kafka broker where the data comes in and then is distributed to the higher level applications. And that would be then Developer Console, Device Campaign Management, and Vehicle Operation Center, as you've seen it in the architectural overview. So this is how we use Hono within Digital Twin. And we use another component actually inside the car that we simulate, because we are T-Systems, we do not build cars, we do not have cars, so we have to simulate them. And we do that by using Kuksa. Eclipse Kuksa, also another open source project. And the architecture is a bit like that. So here inside the car, we would have two different kinds of services. One is a feeder service. So in the end, it just reads the current configuration, the current state of the car, already transforms it in Vehicle Signal Specification standard, and then sends it to the Kuksa data broker, and then is forwarded to the application. Application is then, again, our cloud solution. And there's another service, for example, trunk control service. I would rather call it remote control service. So it will listen for incoming commands, also via Kuksa, to do things like open the trunk, close the trunk, open the door, close the door, and so on. And how is this done? This is basically the abstract view on how it looks inside the vehicle from our point of view. We have these two vehicle signal specification services, the feeder and the provider. They will talk to the signal broker. Oh, there's a typo, great. And this will be then forwarded to the Hypercube digital twin adapter, which will send the data up into the cloud and do things like you have to do device registration, make sure connect security is in place, and the telemetry configuration. So in combination, it looks like that. So you have some cars down here, which are all using Kuksa inside the car. Then we have Hono as a command control interface in between to streamline the data and then forward it to our digital backend. Okay. So let's see how that looks in real life. Here now on the left-hand side of the screen, you have the in-vehicle part, and on the right-hand side, you will have the backend platform. So hopefully that will work. Let's see how it works, great. Prepare the video, otherwise it would be too risky. So on the left-hand side, you have a vehicle, a virtual vehicle, Kuksa vehicle that is being started, and the feeder will start to send out data, prepared data, just a file where you have line-by-line signal information. And then on the right-hand side, so via Kuksa, via Hono, oops, that was too quick. Oh no, it's showing in the database, it's all fine. Okay, on the right-hand side, you had the receiver in the cloud that receives the data in Vehicle Signal Specification standard and then stores it into a database for further usage and also to the Kafka broker to send out the data. That's example number one. I think it's over. Yeah. So now example number two. This is now sending data to a receiver. Now it's the other way around. On the left-hand side, you have the cloud backend platform. And on the right-hand side, inside a Docker container, you have the virtual vehicle that will receive the data and do something. So currently the state is the trunk is closed, and now we will send a remote command to open the trunk. Okay, so we send a remote command doing the same network levels using a certain topic, MQTT topic. It arrives within the virtual car and the trunk is open. Hooray. And the final example is about retrieving the current vehicle configuration. So for an OEM, it's always very important to know what's the current configuration of my car, what's the current state, what is in the car. Most often OEMs, they sell a car, then they go into a workshop, the data record is not updated, so the OEM does not know anymore quite often or almost always what is currently inside the car. So OEMs are very often interested to get direct information from the car itself to know, okay, what is in there, which device, which software version, what's currently going on in there, are there any problems? So this is a very important part. So now again, I have to check what is left side is now. Is the vehicle and the right? No, no, it's still the same. Okay, this is a vehicle. This is backend. Okay. This is the current Verbauzustand, as we say in Germany. So the current setup inside the car with all the details that are relevant for us. Of course, in reality, it would be even much more, but for us, that's the part that is relevant. And this is how it all works together. So, don't know about how I am in the time, but nobody opened the door yet. Seems I have some minutes left. So, time for Q&A. But let me add this first. So in case you are a car manufacturer and you're interested in that, let's talk. In case you are a member of the Eclipse open source community and you would like to collaborate, let's talk. Or if you are a talent and looking for a new job, let's talk. That would be it. Thank you. Are there any questions? Okay.
The second track you mentioned, do you care about the vehicle side at all? So the Kuksa simulation you just had replacing the vehicle, would you expect the OEM to provide the data to your platform, or would you also implement something in the vehicle itself?
We do both. So it depends on, big OEMs, they will not let us put our stuff into their vehicles. That's not an option. So they already usually they have something in there talking Lightweight M2M, MQTT or something, I don't know. And then they tell us, okay, this is the broker, this is whatever the endpoint where the car will connect, where you get the data. Actually, for smaller OEMs, there was one, not sure if I'm allowed to talk about that. Well, I will just do. I don't know have you heard of Ego from Aachen? I think they're bankrupt now, 2 or 3 times already. So they were a potential customer of us. And they were so small, they said, okay, give us everything you have because we just don't have the power to do anything by ourselves. You tell us what we should put in our car, and you also give us this whole Hypercube platform, and that will be then our cloud backend platform one by one. So sadly, they went bankrupt. Otherwise, this would be now a very positive example because we were very confident that we could help them. But sadly, I think they got Neymar as a model, as an influencer for their brand, and that cost too much. Then they went bankrupt. Very sadly, but yeah, the answer is both.
Because we are partially the guys that sit exactly at that point sending out the data.
Okay, you are from.
ICAS.
Okay, I never heard of it. Okay, yeah. Okay, good. So you are the counterpart. You are in the vehicle.
That is what I was
Okay.
counterpart.
Well, that sounds interesting. Yeah. Because actually, it was Ego because we are not that strong. We do some in-vehicle stuff, but not that much. We were working together with Kremer. Do you know Kremer? Yeah. So that was our in-vehicle partner. So usually we are looking for companies that are strong in the vehicle to then do a joint approach. Oh, we don't care. It's just data. Yeah, we take everything that could be interesting. Yeah. If you want to stream that into the cloud, we are open, of course. Usually you don't do that, or you don't do it all the time. You will just do it maybe for debugging purposes. But for these kind of purposes, sure.
But you are using Vehicle Signal Specification VSS?
Yes.
VSS doesn't support another
True.
video data.
That's true, yeah. That's true. You would have, and also the protocols that are listed, they also do not support video streaming. So you would have, in that case, we would have to look, okay, what would you like to do? The device probably would, I don't know. Well, yes, you need you need a dedicated channel, then dedicated protocol for that, and then we need to. But that's, well, in the end, it's just software. It's just data. We do not care. So we also, in the next stage, what we will do, have you heard of the SOVD protocol? SOVD protocol, it supports streaming. We will integrate it into that. It's quite new, so it's not in there yet, but we will integrate it in one of the next stages, and then, yeah, we would support SOVD video streaming. But for now, you would have to open, I don't know, what is a proper video streaming protocol? I don't, and then just, yeah. Exactly. Then you need Deutsche Telekom, 5G. Yes. Yeah. Yes, they always have. Yes, and yeah. Yeah, it's always a lot of work. Yeah, it's always the same challenge. Even with the same OEM, for different models, or even with the same model, they support different architecture versions. And then with the different architecture versions, the protocol usually is the same, but the data encoding is different from architecture version to architecture version, and you need a receiver and a decoder for each of those, because otherwise you will not understand what the car is trying to tell you. Yeah. I already made quite some experience. As we are a system integrator company, usually that's, well, in the end what we do, because Hypercube is not a product. Hypercube is kind of an asset as we see it. So we go to the customer, to OEMs, and show them this is how we see the world. And usually they say, oh, that's quite interesting, but we do it a bit differently. So it makes no sense to sell that as kind of a fixed product. This is rather like a code base. Then we take it and then do system integration work, understand how do you really want to work, adapt it to your data format, to your data encodings, to your processes, and that's where we actually do our work. So this is rather kind of a pre-sales tool. It's not usable out of the box, except maybe for small OEMs like Ego. They don't care and say, just give me everything. I have no standing hardware in place. Welcome. Any more questions? Nope, seems very good. Then, thank you for your time. In case you're interested, I'm on LinkedIn, Sebastian Lang, T-Systems. Feel free to connect with me. I will be happy to answer everything. Okay, thank you.